So I'm going to present this paper made by Facebook in the end of 2016. It's about the large-scale question answering. Here they only they limit themselves to answering simple questions, which I'll elaborate a little bit later. And they use the memory networks framework for this. So, no, 1 second. So the task is to provide answers for simple questions which are stated in natural language, and to do this, I use a knowledge base, which I'll explain what is a bit later as well. Simple questions in this context mean that to answer these questions, only using a single fact from this knowledge base, as in a single query. So the knowledge bases that these guys use are Freebase and Reverb. They use Freebase for actual training and Reverb to do the transfer learning evaluation. So in this knowledge bases, you can retrieve the facts, and they will be presented to you as a like tuple of size 3 of subject, relationship, and the object. So at the time when this paper was released, the common approaches were to either translate your natural language question into the query and run this query against this knowledge base, or embed the questions and the facts from the knowledge base into some common space and then compute the similarities there. This paper does the later. They embed into the space and compute the similarities. So the framework that these guys use called memory networks, it was presented at the end of 2014. It's kind of general framework. Basically, consists of 4 stages. As input, you take the input, you convert it to internal representation. Then there is a generalization stage where you can update the memories of your, like, well, each of these components can be neural network or any other system, literally anything. So during generalization, you are allowed to update the memories that you store and perform any kind of generalization you can think of. Then there is output feature map stage where conditioned on the input and the memories, you output the some internal representation of the answer. And then there is a response stage where you actually convert this internal representation to the format that's going to be presented to the user. And there is a link to the paper. I'll upload the slides later. So the original memory network that was presented in the paper, basically, it was working on the like strings of text. So the very basic version that they had was where they would store the whole input sentence in a memory slot, and then later on they augment this by also allowing to learn this function that will it will basically return 1 when it detects that this subset of input could be separated, like in a separate segment, and it will store those segments. So you would start feeding in the bag-of-4 representation of the some certain window of the text. The window will keep growing as whenever the function decides that it could work with this segment, it will actually fire. You will take the segment away, store it in the memory, and well, start the window again from the next storage. Well, and the generalization slot was actually like just a kind of like slotted storage. Then for the output for internal representation, they would well, this formula is it involves the time extra information about the time when this fact was presented, but initially they didn't have like this part was absent. So it's basically just this is a representation that was computed by the this fee of input. It's a representation that was computed by this initial input module, which is basically, it just does the bag of words of the input. Is there the bag of words for the, oh, sorry, my bad. It uses bag of words only to do the separation. Basically, it's a string of input. Well, no, sorry, it's still bag of words. You use a projection. Yeah, so it's a bag of words of the input that is stored, and then this U matrix is a matrix that basically transforms that input into internal space, whatever it is. And initially they would learn this. Well, initially they would have this the size of this phi initial embeddings would be like three times size of vocabulary. So they would have a separate part of this vector of the separate part of the matrix that does this actual embedding for input part, separate for like the question part, and separate for internal representation, I believe. Well, and then later on they also add like 3 more features to do to encode the time information, relative time information, which basically says like X is the input against which the query has been run. Y is candidate. Y is one of the memory stored, and Y dash is another memory stored. So basically, this function will output 1 if Y is preferred over Y dash, and you would store Y as like the best candidate so far. If the output is negative, you take the. Could you turn off the mic, please? Thank you. And otherwise, you take if the output of the thing is negative, you take the Y dash as a next best candidate, and basically you just iterate from the beginning of your memory till the end of your memory, and store the best candidate answer, pretty much. So this well, and this is some extra embedding that actually takes all it's conditioned on all the inputs that you give it. It well, it does help to take the time into account, I guess. So as there were quite a lot of you could store quite a lot of memories, and since you don't want to actually evaluate like all these memories to run the similarities on the well, it's just dot product here, not class similarity. So since you don't want to compare all of those memories, in case there are quite a lot of them, you would do some bucketing. So the initial version they had was to scan all the sentence, and for each word that there is, make a bucket, and then put each sentence into put each sentence in all the buckets that have the words like that for each bucket, for each containing word, pretty much. Or, well, that approach was not very good because they were not able to answer the question if neither of, if the answer had no matching words with the question. Well, it's actually not a good approach at all. So they decided to use this word embeddings, which not really word embeddings in the context of glove and word2vec and stuff like that. The word embeddings that we used here are pretty much they would feed in the one hot vector for this internal representation, and then the output of this embedding matrix, that would be the word embedding in this case. And they would cluster those things, and then they would only evaluate the candidates from the same cluster as the question is. And well, the response model in this case was they would either output the memory that was stored, that was the most similar, or they would condition, well, and I don't think they implemented the second part, they just suggest that it could be used as well, which is you would utilize any recurrent neural network and condition it on the output and input, and maybe even memory if you want. Well, you wouldn't do memory. Output, input, and you would output the sentence in the natural language. So back to this paper. This paper, yeah, again, tries to solve the answer of the simple questions. And by simple, they mean that the one lookup to this knowledge base is sufficient to answer. So here is an example of from the paper what they mean by the simple question, and here is an example of the query to the, I don't think this is correct syntax, but kind of general idea of it. So Freebase is a knowledge base that these guys use. It's still kind of available, but I think it's hasn't been updated for a while or something. Well, it moved to the other side at least. They use this as a primary source of knowledge. They also make a data set out of it, which I'll talk about a bit later. It's mainly constructed by contributors, by people, so it's kind of reliable. It resolves ambiguities and removes duplicates, and each entry has like entity has aliases, like other names that it could be called by. Entities and relationships have types, and the set of relationship and entities of types are closed. So there are like a certain amount of relationships, and well, compared to Reverb, which I'll talk about later, so it's quite different. Reverb is the other knowledge base that was used to evaluate the transfer and setup. It also was used, well, they also compared the performance on it with this original memory networks paper, which gives some evaluation results on this knowledge base, or on some subset of questions made from this knowledge base. It's basically automatically crawled facts, entities and relationships as strings, so they just well, created by the robot pretty much. Not deduplicated and ambiguous, and have all other problems that could arise by automatically crawling things. So one of those contributions from this paper is a simple question dataset, which is actually still available online. There is a second version of it. You could find it in this link with a bunch of other stuff. So it's a bunch of questions that were written by this by people, English-speaking people, that were shown some of the facts from this Freebase, and they had to come up with a question. And they were like encouraged in different ways to make these questions as different as they could and skip the questions that they were not sure how to pose properly. Also, not all the facts from this Freebase were used to make the questions. They were like selected. First, they removed all the ones that were like where you would have a lot of objects sharing the same subject and relationship thing. Well, example would be a bunch of occupations, and like yeah, and the questions like this are kind of not in the data set. So this particular paper follows the memory network framework, and well, they do call, so for memory networks, the neural network version of it is called MemNN, and they kind of use this name, but to be honest, they don't have much of the neural network component. It's just this embedding thing that computes similarity. I mean, the two matrices that do actual embedding, that's all there is. So for input, however, they do a lot of pre-processing and stuff like that. So for input, they have like 3 different pre-processing things that they do. One is they pre-process the freebase facts. Another they pre-process questions, and they also have another type of pre-processing for this reverb setup, which they kind of call transfer learning, and well, it's a bit weird setup. So for preprocessing Freebase, they first merge a lot of these facts into into single fact. Like every fact where objects share the same subject in a relation will be merged into subject relation and list of all objects. And then also free node is basically it could contain, well, it's hypergraph, so more than 2 entities can be connected by a single edge. That is actually the definition of the hypergraph. So there could be some auxiliary information kind of injected in the graph itself. For example, the time when this certain relationship was valid. And internally, each such auxiliary information is represented as another node that's kind of attached in the middle between the entity and relation. So kind of increasing the effective path between the entities. So all those mediator nodes are removed. This kind of increases the coverage of these questions that could be answered by the single lookup quite a lot, and allows them to simplify the thing quite by a lot as well. So they also use this bag of symbols approach, where they would map the tuples of size 3, right? Well, they would take the entities from this tuple, as in like the subject and the object. Oh, sorry, the facts, they do everything. So they would take, they would construct a set of all relations. They would construct a set of all entities that they have in the data set, and all aliases as well. Like each alias would be like a separate entity as well. And then they encode each fact pretty much by setting position of subject and the relationship to 1, and all objects have value 1 over a number of objects. For questions, they use bag of n-gram representation. Huh. Okay, they do not encode. Maybe I made some mistake with slides. I think they do encode the slices in the facts as well. Maybe they do not. Anyway. So for questions, they would parse the question into the words. They will also check if any of those words is actually a legit entity in the freebase, and if it is, they would if any of the words is allies to any of the entity in the freebase. And they would encode all this as well in the same bag of something representation, where they would set ones for each entity that is present, 0 for everything else. And for reverb facts, they would do the, well, I'll talk about how they process this reverb thing, but basically the size of the vectors is it's same as the sum of the 2 previous vectors. For this generalization model, they store the effects in this certain structure, which is called a multigraph. Well, entities are represented as nodes and the relationship is labeled edges. And also generalization model is used to connect the new facts to this existing data structure. So this is the initial data structure of multigraph is made by parsing this free node knowledge base, while the second sentence refers to the way they add this reverb dataset to it. So for reverb data, they first precompute some entity links, which they do not really elaborate on how exactly they do this. But I would assume that it's related to the similarity of bag-of-words representation. Yeah. Well, they would actually look at the entities and try to match the entities directly, and then just link them. Or if this approach doesn't work, then they search for the aliases within this entity string of reverb. And if that doesn't work, then they just encode the bag-of-word representation of the strings of the entities. And then all the relationship also encoded as bag-of-word of the strings. So pretty much everything is encoded. Like they don't use any. Doesn't matter. It's I think it's a bit outdated approach, but that doesn't matter. So the output model that they have is has two stages. So they don't do the scoring on all the possible combinations. They also first find some candidate facts, and then they do scoring on those. So the way they find this candidate facts is they take the question, they remove all the interrogative pronouns, such as what, why, how, and so on. And then they construct all possible n-grams from this remaining part of the question string, and they try to match it to the aliases of the freebase entities, or freebase entity, like to the entities that are present in the freebase. Then they pick the longest n-grams which match. So they will remove all the ones that are part, like if the entity is a string of 2 words, and it got matched, like, and there are three n-grams that match it, like one of 2, one is bigram, and then other ones are just single grams, or whatever it's called. They would remove those single words and just leave the thing that matches most. And then they would do the scoring. Scoring is just, they would embed this thing into some dimension. They would have 2 matrices that they actually learn. One of the size of this question embedding, another of the size of the fact embedding. They would embed the facts and the question into the same space, do the cosine similarity, and that's the similarity. That's the scoring that they use. And for reverb facts, since some facts are like, well, reverb facts are twice as long as I said before. Not twice as long, but they actually try to match the entities and the relationship as much as they can, but whatever they cannot, they just use the vocabulary. So for embedding the reverb facts, they concatenate those 2 matrices and use that as a matrix to actually do embedding. Well, in the response model here, it will take this highest score output and just take the objects from that and return the objects. For training, they train on quite a lot of things. They first train on these simple questions dataset that they talk about. Then they also have this web questions dataset that was used for evaluation of some previous work, so they could compare the results. And they also generate quite a lot of questions from the extract from this freebase. So 2M means there are 2 million facts, 5M means 5 million facts. And they also do some semi-supervised learning where they kind of refine their embeddings. For that, they have, well, they use some data that was used at that time. It's taken from wiki answers. It's quite a lot of paraphrased questions. There are 15 million clusters of those paraphrased questions, with at least 2 questions per cluster. So for the web questions, since they only use this knowledge like Freebase to answer the questions, they would try to match some of those facts to the web questions. So the way they would do it is they would use this candidate. Same thing as they would select candidates for the outputs. So they would do the embedding of the question, then they would generate the candidates, then they would look through all the candidates, and they would keep those that can generate the most of the of the answer strings that are originally provided with the web question dataset. And then they would loop through all these answer strings and corresponding facts, and then they would get rid of the ones that of the facts. They would pick the facts that answers the least amount of questions, pretty much. So, oh, my bad, with the smallest number of objects. So the least general. And they discard all the questions that they do not have any candidate facts whatsoever. These are the losses that they use to train this two matrices. Pretty much standard max margin kind of ranking loss. Square brackets and plus here means that it's a maximum. It's a positive part of this thing. So it's if the part inside the brackets is negative, it's just 0. And they minimize this. So the first part of the loss is like this is the embedding of this is similarity between the question and correct answer. This is similarity between question and incorrect answer. So they maximize the similarity between question and correct answer, minimize the similarity between question and incorrect answer. And similar thing for semi-supervised paraphrase loss. So this part is they want the embedding between the paraphrases be similar and the embedding between different questions be different. So the way they sample these things for the losses before is for paraphrases, they just do the random sampling from the remaining clusters. And for question answers, they do 2 different things. First, they do the corrupting, well, they evaluate it in 2 different setups. So the first setup was that they would take the correct fact and they would corrupt the subject of the fact, like switch it to something else, and then with some probability they would also switch the object or relationship. And the other thing which they tried and it gives better results is they would sample at random from the remaining candidates that are not the best candidate. Oh, and some other details about the training is after every update, after every update is finished, they would normalize the columns of the embedding matrices, like on the unit sphere and stuff. They would use warp loss, which is basically they keep sampling in the setup as here until you actually get the violation, like until you actually get the positive loss, and then you do update. Add-a-grad is optimization where you store the sum of the squared of the gradients, and it's not a sliding sum, but it's actual sum. So it's not a very good optimizer, I think. And Hogwild is an approach to do this parallel training where you disregard any lock-in mechanism and you just overwrite the, well, you just update the weights in shared memory. Oh, I didn't remove this. Well, they have a little bit of weird things on how they actually do this experimental setup. So first of all, for this transfer learning thing, for reverb questions, they only like evaluate the candidates that evaluate are only this reverb subset of facts that they store as well. And well, never mind this part, it's not supposed to be here. Well, they also do quite a lot of different things that are different from the stuff that they compare with. So Borders, I believe this is the guys who made this memory networks framework. So they were evaluating on this web questions database as well, and they were also using this Freebase knowledge base, but they would not do such a preprocessing as these guys did. Like if the question involved multiple objects, they would actually scan through multiple facts and they would concatenate the answers together and stuff like that. And they also did not remove this auxiliary nodes, like mediator nodes. So I don't actually remember if they searched like longer paths through this through the knowledge graph, or they just didn't answer those questions. Anyway, the results from these Facebook guys like are not that good compared to this original paper. It's actually very similar. And take into account that the preprocessing that they did, it's not, well, I think this was the result from this original paper, and this is the result that these guys got in the similar setup, but with all the preprocessing that they did. However, this original memory networks paper, they also had another, well, they did not use the vocabulary for the question, they had entities for everything, so. And well, here are results. So basically these are results from everything that was available before this paper that they found. And I think there is a typo as well here. Well, okay, great. As you see, they show the random guess setup and they have 35 here, which hopefully is 3.5. Because if it is 35 and random guessing, that means that the quality of questions is terrible. Or like there are a few combinations, three choices of answer. But surprisingly enough, the transfer learning setup like gives a decent result comparing to this original guys who actually trained on this data set. It's like all this is F1 scores. Oh no, this accuracy is my bad. What else? Oh yeah, for results. So this is a table with results. All of this memory networks or whatever it is, they were trained on this automatically generated questions first, and then this is like extra data sets. And you can see that having this paraphrase things training actually increases this reverb accuracy by quite a lot. Yeah, for the variants that were not trained on it, they have quite a lot less score. And that's pretty much it. If you guys have questions, feel free to ask. Well, if there are no questions, have a good night and stuff like that.